Hi Algebra 1 students, this is Mrs. Richart. Today we're going to look at solving linear equations, a system of linear equations using elimination, day 2. So yesterday you worked with Mr. Tremor in his video on using elimination to solve systems, and he taught you how to add equations together so you can eliminate a variable. Let's take a look at this problem. 2x plus 7y equals negative 19, and 2x minus y equals 21. This is a system of equations. We want to find the solution for this system, so it has to be a point that makes both equations true. If we do what you did yesterday with Mr. Tremor, and we add the equations, notice how I get 2x plus 2x is 4x, 7y minus y is 6y, and negative 19 plus 21 is 2. We're no better off than when we started. The point of elimination is to eliminate a variable so you can only solve for one variable at a time, but this didn't help us. So we need to eliminate one variable by adding the equations together. Today we're going to look at how can we manipulate the equations so they can be added. Let's revisit the opening example number 1. So if you notice, we're looking for a positive 2x and a negative 2x, or a positive 7y and a negative 7y. We're trying to add the equations so we can eliminate one variable and solve for one variable at a time. If you multiply an entire equation by something, the left and the right side by the same number, we're not changing the equation. So it doesn't matter which one you do it to. I want 2x minus 2x. So I'm going to multiply this equation by negative 1. I'm just going to go ahead and rewrite this equation. Negative 1 times 2x is negative 2x. Negative 1 times negative y is plus y. And negative 1 times 21 is negative 21. If you want to put both sides negative 1 on both sides, you can do that. I just put parentheses to show that I'm multiplying the entire equation by negative 1. Over here, for the equation at the top, I'm not doing anything to it. I'm just going to rewrite it so I can add the equations together easily. At this point, I see that I have a 2x and a negative 2x. So this is like what Mr. Tremor showed you yesterday. 2x plus a negative 2x is 0x. 7y plus 1y is 8y. And negative 19 plus a negative 21 is a negative 40. So now we have one variable that we can solve for. So if we go ahead and divide both sides by 8, I get y equals negative 5. I can plug this into either equation. So I'm going to go ahead and plug this in for y right here. So if I write the equation 2x minus something equals 21, and I replace that y with our negative 5, now I have one variable to solve. So I have 2x plus 5 equals 21, and if I subtract 5 from both sides, I get 2x equals 16. If we divide both sides by 2, we're left with x equals 8. So I have an x and a y. So if you notice, this solution to this system is 8, negative 5. 8, negative 5. That means if you plug these into Desmos, you will get an intersection point at 8, negative 5. 8, negative 5 make both of these equations true. Let's take a look at another one. So we have negative 5x plus 1y equals negative 3. 3x minus 8y equals 24. If we look at this, I want to see if I can make the x's match or make the y's match. Well, I can't make 3 become a negative 5 or negative 5 become a 3 easily, but I can make 1 become an 8 easily. So I'm going to go ahead and multiply this equation by 8 because I want a positive 8y, so I can do 8y minus 8y to get 0. So I have 8 times negative 5x, which is negative 40x, 8 times y, which is 8y, and 8 times negative 3, which is negative 24. So I'm going to go ahead and rewrite the bottom equation so everything's lined up. 3x minus 8y equals 24. If we add these together, I have negative 40x plus 3x, and that's a negative 37x. 8y minus 8y is 0, y, and negative 24 plus 24 is 0. If we solve for x and we divide both sides by negative 37, I get x equals 0. You can go ahead and plug this into either equation. The whole point is to eliminate one variable so you can only solve for one at a time. So I have 3 times something minus 8y equals 24. That something that I'm going to be plugging in for x, we know, is 0. So if you continue to solve, 3 times 0 is 0. So we have negative 8y equals 24. If we solve for y, we get y equals negative 3. So the solution to this system is 0, negative 3. That's where our graphs intersect. If we take a look at this, I have 8x plus 14y equals 4 and 6x plus 7y equals 10. Well, I don't have a plus and minus that are lined up already, so I might need to make one equation become another when you're looking at the x or the y. So if I see this, I have 7y and 14y, and I notice that that's times 2. So if I go ahead and multiply this equation, if I multiply it by 2, I'm going to get 14y, but I want to multiply it by a negative 2 because I want to have opposite signs. So if I multiply it by a negative 2, negative 2 times 6x is negative 12x. Negative 2 times 7 is negative 14y. And negative 2 times 10 is negative 20. I can go ahead and rewrite the top equation. 8x plus 14y equals 4. Now we're ready to add. The reason why I know that we're ready to add is because 14y minus 14y are going to cancel to give us 0y. So 8x minus 12x is negative 4x, and 4 minus 20 is negative 16. So now we have one variable to solve for. If we divide both sides by negative 4, we have x equals 4. Once again, you can pick either equation to plug this into. I'm going to plug this in for x. So I have 6 times something plus 7y equals 10. And that something is 4, because that's our x. So we have 24 plus 7y equals 10. If we subtract 24 from both sides, we have 7y equals negative 14. From there, if I divide by 7, I get y equals negative 2. So that means 4, negative 2 is the solution to this system. The last one we're going to look at, I have negative 7x minus 8y equals 9 and negative 4x plus 9y equals negative 22. I don't see how I can easily make the negative 4 into a 7 or the negative 8 into a 9, so I'm going to need to multiply both equations. To figure out what you need to multiply both equations by, we need to see what they're factors of. So you can do this multiple ways. Negative 4 and negative 7, I know they both go into 28. Negative 8 and 9, I know they both go into 72. It's kind of whatever you want to do. I'm going to want a 28x and a negative 28x. So I'm going to try that first. So I'm going to go ahead and multiply this top equation by a negative 4. This is going to be my positive 28x. So I have 28x. Negative 4 times negative 8y is 32y. And negative 4 times 9 is negative 36. Because I have a positive 28, I'm going to multiply this second equation by 7, so I get a negative 28x. 7 times negative 4 is negative 28x. 7 times 9y is 63y. And 7 times negative 22 is going to be a negative number, and it's negative 154. So now we're ready to go ahead and add straight down. We had to manipulate both equations this time. 28x minus 28x is gone. And 32 plus 63 is 95y. And so we're going to set 95 equal to negative 36 plus a negative 154, which is negative 190. Now we can divide both sides by 95. And we get y equals negative 2. So just like before, we can plug this into either equation. So I have negative 4x plus 9 times something equals negative 22. And that something is negative 2. So now I can solve for one variable at a time. Now I can solve for my x. Negative 4x minus 18 equals negative 22. If we add 18 to both sides, I have negative 4x equals negative 4. If we divide by negative 4, I have x equal 1. So 1, negative 2 is the solution to this system. Now go ahead and work on today's Kami practice. I know this was kind of a long video for today. Feel free to look at the PDF notes as well and start and stop this video if you need to rewatch anything. I hope you have a good day and ask your teacher questions.